If you've heard about quantum computing, you've also heard of qubits. And you've probably also seen this depiction of a qubit. This is called the Bloch Sphere, and I will now explain what this is. The Bloch Sphere is a visual representation of the state of a single qubit, making it easier to understand things like superposition or quantum gates, and which effect they have on qubits. A qubit is the basic unit of quantum information, analogous to a bit. And like a normal bit, a qubit can be in one of two states, which we simply call 0 or 1. We can visualize this much like a normal coordinate system, with the two states being orthogonal to each other because there's something completely different. But the difference is that the state of a qubit can also be in a superposition, a mixture of 0 and 1. And in our state coordinate system, this would be any direction except 0 or 1. These two states are equal mixtures of 0 and 1, just with a different relative phase. As these two are also orthogonal to each other, they can be used as an alternative basis instead of 0 and 1, and we call these the plus and minus states. Now, another important thing. Half of all the states in this coordinate system are mathematically different, but are physically identical, because they only differ by a global phase, the phase factor for the entire state, and this makes no difference when measuring physical states. Therefore, we can make better use of the available space by rearranging the coordinate axis. We just need to remember that in this system, orthogonal doesn't mean 90 degrees anymore, but 180. Also, as complex numbers are used to describe quantum states, we have two additional basis axes that are also orthogonal, the plus I and minus I states. All quantum states represent a probability to measure certain outcomes. And as the total of these probabilities must always sum up to 100%, the length of any state vector must always be exactly 1. Therefore, all the possible states together form a sphere. The Bloch Sphere, named after physicist Felix Bloch. You can use it to quickly and clearly visualize any state a single qubit can be in, and also how a state evolves over time. So it is a pretty useful tool to understand what goes on in a computation. Subscribe for more quantum computing.